Hey folks, welcome to part 2 of 8.3 multiplying and dividing rational functions. In this video I'm just really focusing on the dividing part of it, and dividing fractions is actually pretty simple. Basically the way fractions work is when you divide them, it's the same thing as flipping it and multiplying. So this is what I mean. It's the same exact thing as saying 7x over 2x minus 10 times x squared minus 11x plus 30 over x squared minus 6x. So with that being said, it's just going to be like it was in the previous videos. We need to factor some stuff out. We need to identify our asymptote, or I guess where our domain is restricted. But yeah, that's basically how you're going to approach all these. Is the first thing you need to do is just flip one of the two fractions. I always just flip the second one and then just multiply. So for starters, I'm going to factor the bottom one, or I should say the denominator of the first fraction. So this has a common factor of 2. All right, I can divide 2 from 2x, that leaves behind x. And I can divide 2 from 10, that leaves behind 5. All right, and then on top, we have, let's see here, I'll just keep it all in one fraction. Because when you're multiplying, just multiply straight across. You can write it all in one fraction, it doesn't matter. What are my factors of 30 that add to negative 11? Well, let's see here. So we got 30, negative 11. I know 6 times 5 makes 30, and if I make them both negative, that still makes a positive 30 and adds to a negative 11. So I'll say x minus 6 times x minus 5. And then on bottom, I see I have an x squared minus 6x. So what do they have in common? They both have an x. So I'm going to factor out an x. So it's going to say x times, and that'll leave behind x minus 6. All right, so here you have, and if you want, you can erase the x and the 2, and then you can write it as 2x times x minus 5 times x minus 6. So basically, we have a restricted domain at 0, because 2 times 0 would make 0. We have a restricted domain at 5, because 5 minus 5 is 0, and 6 minus 6 is 0. Okay? And then we can just start canceling stuff out now. X minus 6 cancels, x minus 5 cancels, and then the x's here cancel. So the answer is just 7 over 2. So f of x equals 7 over 2, or you can even say 3.5. But yeah, that's it on that one. Okay, so I'm going to do the one right underneath it next. All right, so, excuse me. Okay, so see this second fraction, or second expression is not a fraction. So if you want, throw it over 1. So when we flip it, I am going to write it as 1 over 3x squared plus 5x. Okay, so I just did a little copying and pasting there. So that's what's happening. I'm doing 6x squared plus x minus 15 times 1, and then over 4x squared times 3x squared plus 5x. Okay, so let's do a little bit of factoring here. Let's see here. If you have a number in front of the x squared, remember you need to multiply it to the back. So 6 times 15, that's going to be 90. So I'll write negative 90 since it was a negative 15. And then there's just a 1 in the middle term. So what are my factors of negative 90 that add up to 1? Well, 90's got a lot of factors, but 10 and 9 are only 1 apart. So if I do 10 minus 9, that adds up to 1. If I do 10 times negative 9, that multiplies to get negative 90. So I think we got it. So we're going to say x plus 10, x All right, let me just erase that. So we got x plus 10 times x minus 9, and then you have to divide out that front number. All right, so we're going to divide out 6. So let's see here. 10 over 6 would simplify. Let's see here. That's going to make, they can both cut in half. That's going to make 5 over 3. And then 9 over 6, that'll simplify too. They can both divide by 3. So that'll make 3 over 2. So you remember, you want to simplify the fractions, but you don't want to leave it as a fraction. You want to take the denominator of that fraction and swing it up front. So it is saying 3x plus 5 times 2x minus 3. Okay? So basically, all this work is just going to replace this right here. All right? So with that being said, let's just rewrite everything now. Before I rewrite everything, I want to factor out the greatest common factor of this. So instead of having 3x squared plus 5x, I'm going to factor out an x. And so I'm going to say x times 3x plus 5. And so that is something I can rewrite using what I just did with my factored form. And so now I have everything factored out, and it's ready to cancel stuff out. I guess before we cancel things out, we should write where the domain was restricted. So the domain is going to be restricted. Let's see here. If I plug in a 0 here, squaring it will still make it 0, and timesing it by 4 will still make it 0. So I can't plug in a 0 here or here. And then I can't plug in a negative 5 over 3. And then a quick way of doing that in your head is we just did the work up here. Plugging in a negative 5 over 3 would make that go to 0. This is the same thing as this. See how it turned into 3x plus 5? You could also write it like this. You could also take that 3x plus 5 and then write equals 0 and then minus 5 to both sides and get 3x equals negative 5. Divide by 3 and you get x equals negative 5 over 3, which is what I said before. So, either way you want to go about it. But yeah, so we're going to say that x can equal 0 and negative 5 over 3. And then, sorry, I'm just moving this thing all around. And then let's cancel out our like terms. So we have 3x plus 5 can cancel. 2x minus 3 isn't going to cancel with anything else. So it's going to look like this. It's going to say 2x minus 3 over, and then let's go back and look. We have 4x squared times x, so that's going to give us 4x to the third power. So I'm going to say 4x to the third power. Don't forget to write, f of x equals, okay, and then we said that x could not equal 0 or negative 5 over 3. And so that is the final answer in that one. Took a little bit longer to do, but mostly it was because this factoring step took a little bit longer, which that's always going to happen when you have a number greater than 1 for the a value. Okay, so with that being said, these two examples are pretty similar to the ones I just did. So why don't you pause the video and try and work these out on your own, and hopefully your answer will match mine. Okay, so for this one, I went ahead and I flipped the fraction and when I wrote this step. And so my factors of 15 that add to negative 8 are negative 5 and negative 3. And if you need to see the work for that, factors of 15 that add to negative 8. Negative 5 plus negative 3 is negative 8, and negative 5 times negative 3 is positive 15. All right? And this one, they had an x in common, so you could factor out an x and say it's x times x minus 5, okay? So then flip the fraction and multiply, and then the 3 times x minus 3 came from me factoring out a 3 right here because they both have that in common, because 3 times 3 is 9. So that's how I got everything I wrote in black. And then I just canceled out like terms, x minus 5 over x minus 5, x minus 3 and x minus 3. And then I have an x here and an x there. It doesn't matter if that has a number by it or not. Technically, this 3 is by the x, if that makes you feel any better. So it's like 11x over 3x. X's would cancel. Anyway, everything cancels out. You're just left with 11 over 3. And then where was the domain restricted? You couldn't plug in a 3 here. Couldn't plug in a 0 there or 5 there. So that's where I got x can equal 3, 0, or 5. The next one was a little bit tricky because you see how it says 6x squared plus 4x minus 2? That has a greatest common factor of 2. So you need to factor out the greatest common factor before you do the first number times the last number. If you don't, you wind up with this answer, what I have in blue, but you don't have the 2 on the outside. So that ends up affecting your final answer just a little bit. I'll get to that when it comes up again. But factor out your greatest common factor of 2, then multiply the 3 times the negative 1, and so that gives me a negative 3. And so factors of negative 3 that add up to negative 2 are 3 and negative 1. So 3 plus negative 1 is 2, and 3 times negative 1 is negative 3. Then you have to divide out that front number that you just multiplied back, because I got x plus 3x minus 1. So 3 over 3 makes 1. And then 1 over 3 would make 1 over 3, so swing that number up front. And so I have 3x minus 1. And then don't forget, see how I wrote the 2 on the outside the whole time? So this became the top of this, so that's why I just put the arrow there. So I rewrote it here. And then 5x squared still stayed on the bottom. And then looking at the other fraction, it was just 2x squared plus 2x, and it wasn't a fraction, so it's technically over 1. But remember, you have to flip it and multiply. So I drew the 1 on top, and then I just changed that to a multiplication sign. And then these had a common factor of 2x, so I factored out 2x from both. So that was behind an x plus 1. So I wrote it right down here. So if I'm multiplying across, I'm doing 5x times 2x times x plus 1. So you notice how I just wrote it as one fraction. Saves a little bit of space, I guess. So what canceled out? Just the x plus 1s, but notice how I had a 2 on top here and a 2 there. So yeah, those could totally cancel, and that would just leave behind this x and the 5x squared. So that gets me a 5x to the third power on bottom. And then what was left over on top? Just a 3x minus 1. And so you can't plug in a 0 here or here. And you can't plug in a negative 1 there. So that's where the answer is restricted. So if you hadn't factored out that 2 early on, you still would have gotten x plus 1 and 3x minus 1. But then how would that have changed your answer? Well, these 2's wouldn't have canceled out, and you would have, it looks like you would have, I guess, a 10x to the third on bottom. So that's how it would have changed it. And so that would have made it wrong, you know. Just a little bit, small error, but it does make it wrong. So just remember to keep an eye out for greatest common factors. Here's how I do it. If I made the mistake of not taking out the greatest common factor, when I get to this step, if I look at it without the 2 there, and I'm like, well, the front number was 6. So remember, this can like multiply back out and get the exact same function. And so I'm like, this is going to be 3 times x. That's going to lead with a 3x squared. It's not going to get bigger. So I'm like, why isn't it getting 6? And then I see that I'm like, oh, they're all even numbers. So they all have a greatest common factor of 2. So I go back and I restart it. Or you could just throw in a 2 on the outside. If you know you're off by whatever factor, that's because that was the common factor that you just forgot to do it. So you can always just throw it on the outside at the end if you didn't catch it until the end. Okay, so I hope that made sense. But yeah, that's going to wrap it up for these notes. I hope this helped, and thanks for watching. Bye.